So we wrap up the chapter here with what we call explicit and recursive, right? Explicit and recursive. We do recursive first. Recursive, what word does recursive remind you of? Right, probably reminds you of like recurring, right? It's a recurring pattern. So a recurring pattern is basically the recursive formula. So you're using the previous numbers to help get the pattern for the next numbers. So we already know that a sub n is the nth term. We know that that's not the same thing as n, right? N is like the place of the term in line, and a sub n is the value of that term. But now we introduce a sub n minus 1, the term before the nth term, and a sub n plus 1 is the term after the nth term. So this is what I call math secret code. So what is this telling you in number 1? If a sub 1 equals 2, it's telling you the first term is 2. Here's this real secret code. A sub n equals a sub n minus 1 minus 3. A sub n minus 1 minus 3. So that's saying to get to the next term, you take the previous term and subtract 3. So 2 minus 3 is negative 1. I'm getting that from 2 minus 3. What's the third term? The third term is the second term minus 3, or negative 1 minus 3. Oh, I get it. You're subtracting 3 each time. If I'm subtracting 3 each time, is that arithmetic, geometric, or neither? Right, arithmetic. Try the next one. The first term is 24. A sub n is equal to 1/3 a sub n minus 1. What's 1/3 of 24? Right, 1/3 of 24 is 8. What's 1/3 of 8? Always as a fraction. 8/3, 8/9, 8/27, and that is arithmetic, geometric, or neither. Right, geometric, because we're multiplying by 1/3. Next one, combo. It's telling you the first two terms are 4 and 12, and then it's saying to get the nth term, you do what? Take the n minus 1 term minus the n minus 2 term. So that's saying take the term before and subtract the term before that, right? So take the term before minus the term before that. So 12 minus 4 is 8. And then similarly, this one would be 8 minus 12, negative 4. Negative 4 minus 8, negative 12. That's a neither. It's not adding each time. It's not multiplying each time. It's just kind of a pattern. So this brings up the famous Fibonacci sequence, 1, 1, 2, 3, 5, 8, 13, where you're adding the previous two numbers. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8, right? And so this is how we could describe the Fibonacci sequence. They have to have two numbers given, and then the number before plus the number before that. So you can think about that for a second, because that's a little tricky. And then here's some where it's like, it's not always combinations of numbers. Like I think in the first one, isn't it just adding 4 each time? Common difference is 4. So I would say, okay, the first number is 3. The nth term is the term before plus 4. And that's all. What's happening in number 5? Arithmetic or geometric? Right, geometric. Common ratio is 2, so I would say the nth term is 2 times the term before. The one that's like Fibonacci is number 6, where you've got like, it's like a neither. So if I'd say the first term is 20, the second term is 15, how am I getting 5? Right, 20 minus 15 is 5. 15 minus 5 is 10. 5 minus 10 is negative 5. It's always the term 2 before minus the term immediately preceding the term. So we know that those are the hardest ones, but it's still, doable. There's one like that on the test. And then we're down to the last thing, which is explicit formula. Explicit formula takes you right to the term, right to the nth term. And it uses our old friends here, the n-term formulas. It's basically like a summation, you'll see. If a sub n is 2n plus 1, what's a sub 1? Well, wouldn't I just replace the n with 1 and get 3? Replace the n with 2 and get 5, and then get 7, and then get 9, and then even if I jump to here, it's just plugging in a 10 or plugging in a 15. That's just basically adding 2 each time. I bet you can guess what this one's going to be with that n in the exponent. Right, it's going to be geometric. And again, I'm just plugging in. Now, geometric ones can get a little crazy. Negative 2 times 3 to the first is going to be negative 6. Negative 2 times 3 squared, what's that? Negative 2 times 9, which is 18. Negative 2 times 3 cubed, oh, actually it's negative 18, sorry. Negative 2 times 3 cubed, negative 54. I'm already getting a little bit. Negative 2 times 3 to the fourth is 81, so what's that? Negative 162. But when I get to like the 10th, I can just write it as negative 2 times 3 to the 10th. Negative 2 times 3 to the 15th. That's fine. This, where a sub n equals n squared, it's just 1 squared, 2 squared, 3 squared, 4 squared, 10 squared, 15 squared. It's not really adding or multiplying, it's just an even. When you write an explicit formula, then you're following the a sub n rule if it's arithmetic or geometric. So this one here looks like I'm adding 3 each time, so it's arithmetic. So I'm going to use my arithmetic formula. Leave n as a variable. So this is 3 plus n minus 1 times 3, or 3 plus 3n minus 3, or a sub n equals 3n. And that would get me any term. This one, of course, is geometric. The r looks like negative 1/2, so now I'm going to use my geometric formula. So it's going to be 1 times negative 1/2 to the n minus 1. And you can leave it like that. You technically don't need the 1, but you can just leave it like that. The neither ones can be tricky. Like, I just kind of look at that and say, like, okay, if n is 1, it's 1/4. If n is 2, it's 1/8. If n is 3, it's 1/12. It's always 1 over 4n. And I could probably just figure that one out in my head. So there we have it, explicit and recursive formulas.